An overview of correlation. Suppose a safety inspector wants to find out if there is a relation between the number of hours of training for an employee and the number of accidents involving that employee. Or suppose a psychologist wants to know if there is a relationship exists between the number of hours a person sleeps each night and the person's reaction time. How would that person determine if there is any relation exists or not? This is the job of a statistician. What are we going to do? We're going to come up with some important statistical analysis and techniques. In this section, you'll study how to describe what type of relationship or correlation exists between two quantitative variables, and how to find that correlation, is it significant or not? Well, let's begin by talking about the definition of a correlation. A correlation is a relationship between two variables. The data can be represented by an ordered pairs x comma y, where x is independent or free or explanatory variable, and y is depending on x, so that's why we call it dependent or response variable. The graph of ordered pairs x comma y is called a scatter plot. In a scatter plot, the ordered pairs like x and y are graphed as points in coordinate planes or xy plane. The independent or explanatory variable x is measured on the horizontal line, and the dependent or response variable y is measured on vertical axis. A scatter plot can be used to check to see if a linear correlation exists between two variables or not. For example, if you have two variables, variable x on the horizontal line and variable y on the vertical line, and here you have a bunch of points representing x and y in the plane. As x increases, y tends to decrease. So as you're going to the right-hand side on the horizontal line, x increases in values. But take a look at y values. The y values start decreasing. So the regression line here basically is a decreasing line. So the behavior of your regression line or the linear relation is decreasing. It starts decreasing. However, here you have a positive linear correlation. Why is that? As x increases on the horizontal line, your y increases on the vertical line as well. So basically, your regression line has positive slope. It is increasing. There is no correlation in this scatter plot. There is a chaos here. As x increases, there is no information about y. Some of the points are just increasing, some of the points start decreasing, so there is no correlation here. In this case, we have a correlation, but this is non-linear correlation. So as you can see, this is like a parabola. It's non-linear correlation. In our class, we are interested in analyzing linear correlation between data. Well, how did we construct the scatter plot? We're going back to algebra to do the job, but we need some information first. An economist wants to check to see if there is a linear relationship between a country's gross domestic product, GDP, and carbon dioxide, CO2 emissions. The data are shown in the table on the left-hand side. So your X values, which is GDP in trillions of dollars, are listed on the left-hand side. 1.7, 1.2, 2.5, and so on. And the CO2 emission, the carbon dioxide emission, is depending on X. Well, let us graph this and visualize the data first. If you want to visualize the data, start by having X values listed on the horizontal line and Y values listed on the vertical line. You're going to scale them. As you can see, on the horizontal line, you have 1, 2, 3, 4, 5, 6, which are representing these numbers. As you can see, these numbers comparing to these values are small. You have 1.7, 1.2, 2.5, 2.8, 3.6, and so on. So these numbers representing GDP in trillion of dollars on the horizontal line or free variable, independent variable is X. Explanatory variable is X. On the vertical line, however, you have the dependent values, Y values, but Y values are 552.6, 462.3. So if you look for the smallest value, it seems like the smallest value is 253. So we're going to start by scaling this from 200 and going up to the maximum value of 1,200. Why 1,200? Because the maximum value in our collection is 1,180.6. The very first point, which is this point here, is related to 0.8 and 253. 0.8, which is going to be roughly here, and 253 is about here. So if you connect these two together, you get to the first dot, which is this dot here. The next value, let's look for the next value after 0.8. It seems like the next value is 1.2 with Y value 462. So 1.2, which is roughly here, and then 462, which is roughly here. Almost. If you connect these two together, you get your second dot, which is located here. You continue this process and graph the rest of these data. But what do we see here? We see that, hey, there is an increasing trend. As X increases, Y increases as well. So if you were to graph a regression line, you're going to say that, hey, I see an increasing trend here. Reading from left to right, as the gross domestic products increase, the carbon dioxide emission tend to increase as well. So these are visual representation of what's going on here. But how do we do the calculation? What is the correlation coefficient? Constructing a scatter plot, a student conducts a study to determine if there is a linear relation between the number of hours a student exercise each week and the student's GPA. That's an interesting question. Is there any linear relation here? The data shown here shows the number of hours of exercise, which is changing freely as X, 12 hours, 3 hours, 0 hours, and so on, and Y values, the GPA for that student that exercise 12 hours is 3.6, exercises 3 hours, 4, and no exercise at all with GPA 3.9, and so on. Well, let's visualize this data. Do you see any relation here? Do we see any correlation here? The number of hours a student exercise each week doesn't appear to be related. At least there is no linear relation. So since the data are just scattered all over these points, we say that, hey, we don't see a linear correlation, linear relation between these two variables. There is no linear relation between hours of exercise and GPA. So this is the visualization of scatter plot and how to analyze the data visually. But what is the math behind it?